and this. Feel the vibe. Feel the vibe. Sounds like this. And this. And this.
Okay, hi everybody. On to talk 4A on Programming Fundamentals on the Higher Diploma in Computer Science. Hopefully everybody can hear me okay today. We're on the Slack channel. Give me a thumbs up if you can hear the voice loud and clear. Okay. Yeah, thumbs up. Okay, so I think we have the levels okay for today. I'm already recording, so we'll be able to watch this back later should you have any questions. Let's get started today by looking back on what we went through last week. I've put up a couple of web links in the bottom right hand corner, and these will take you to the notes for today and also some websites that are mentioned within the notes. So it might be no harm for you to open each of those web links and have those ready so that you can have them ready in your browser. Okay, fair enough. So I just want to have a recap on some of the materials we've already covered. Last week we covered methods, which are also known as functions. We looked at the signature of the method and also the body. The signature had a return type, a name and parameter list, and the body had statements in curly brackets to achieve a particular task. We also saw that we can call these methods in our code, so it makes our code nice and reusable. And if we look at some of the examples that we finished up on, we had some questions in one of the sessions. I thought it might be an idea to post some of the solutions here. So we had an example of void just do it. So this is a method that gets called. It does some function and that's it. I'm just noticing that I launched a web link. It takes a bit of time, but it actually ended up taking over your screen. So let's close those back. Let me close that back out. And I'll just return here. Okay. So this method is called just do it. Sorry, apologies. I just noticed your screen is changing. Let me clear that. At the moment, you're seeing a set of slides which I don't particularly want you to see, so I just got to figure out what's going on. Give me 1 second, please. Okay, I just got a little bit of a muddle there. One, two. Okay. Okay, you can hear me again. Just want to make sure. Yeah. Okay, apologies, guys. Just got in a bit of a muddle there. We're running those web links. I didn't realize that when I open the web link, it launches it on your screen and takes over your screen. So I'm just a little bit thrown there. Okay, back to what we were looking at. So um, we're looking at this method, just do it. And we said that this will just print out to the console, just do it. So it has a signature, which this signature has a return type, a void. It has a name, which is just do it, and a parameter list, which is empty. The body then is inside curly braces, and that's the code that you run, what you want to happen when the just do it method is called. We also looked at other examples. We saw that you could have, you could pass in multiple parameters. In this case, we're passing in int x. So this is called a parameter. We have another example here, which returns a value. And when we return a value, we use the return statement inside the method, and then the method name returns a value that can be stored inside a value, inside a variable in a call. We saw lots of those examples. Here's the calls. So the first one would be just do it, open bracket, close bracket, semicolon. And what this is doing is just calling the method. Second one, just do it 3 times. So we passed in the 3 for x. And then in the third method call, we're saying number of times is assigned a value. Do it and tell me how many times you did it. Okay, so these are, we spent quite a lot of time looking at methods last week. And in the labs then we looked at eyes and we looked at the x's. You were asked to draw an eye, draw 2 eyes, draw 6 eyes, draw 100 eyes. And just before we came live today, I also put up an extra little question. How would you use the x's? So if you know how to draw 1x, we've seen how to draw 3 x's with different properties. We passed in color, weight, x and y location, and the size. And what I was asking you to do just before we came live today, you might think about it, is how would you use this x to create a diamond pattern on the entire background? So that's one maybe to work on. Last week we also looked at converting from Fahrenheit to Celsius. We looked at overloading, and overloading is quite an important concept which we'll be coming back to today. Overloading is used in objects to provide multiple methods with the same name, but if the number of parameters is the same as another one, then at least one parameter type must be different. So this was an important concept, and we covered that in the questions in the last session. We also moved on to recursion, and we saw that recursion is where we have methods that call themselves. So there's a line of code with a method call calling the method that's in which this line of code appears. And the problem with that is that we could end up with infinite calls. So we learned about the base case, and we said you exit recursion using a base case to prevent infinite method calls. And there were some examples of those in the lab as well. And then we got on to strings. We started with strings, but we didn't finish it off. So I'm going to start there today. So we're going to start with the notes from talk 3B. And we got as far as looking at char C equals, in single quotes, the letter C. So this is storing a Unicode character for code for C, and it stores it in the variable C. The important thing here is with the char data type, you can only have one character, and it must be inside single quotes when you're doing an assignment statement. And then we moved on to the string, which introduced us to objects. So we said string is not a primitive data type in Java, it's an object type. And what this means is that it has a capital S for the data type. And we're going to be looking into objects more today. And we'll be looking at more of the methods that are inside the string class, and that's going to be the main topic of today. So the stuff that we didn't cover, we'll be going over that, and then we'll be just extending it on to today. So today's class, strings, more on strings, looking at the index of characters. We're going to be looking at string methods, Examples: char at, substring, and compare to. And we'll also be looking at some issues that come up when you're writing logic. And we have some examples of where it's very easy to make mistakes with ordinary arithmetic logic. We're going to see that strings can throw up some issues as well. So we're going to be identifying or looking at string identity versus equality. We're looking at some additional errors that pop up with strings, the null value, and escape sequences. So we'll get through all of those today. And hopefully we'll get on to classes and objects as well, which will back up some of what we've been talking about. Classes and objects are the same thing. The class is the template. The object is an instance of a template. And these have properties, which are referred to as fields in processing. We have variables and attributes, all meaning the same thing. And then we have methods which work on those properties. We can't talk about classes and objects without talking about dot notation, which we've already used, but we'll be revisiting. And then we'll be creating your first class in processing called Spot. And that will take us on to constructors, which we may probably not get onto today, but at least you'll be able to read ahead. Okay, so let's start here. Let's bring up our slides from the last day. Okay, so we stopped at primitive types versus object types. So let's continue from there. So a primitive type is what we've been using up to now, which is the built-in data types in Java. Here we have an example of int I is assigned a value 17. And what we're saying is that value, or that number 17, gets stored in memory. And that memory is referred to, that memory location is referred to as I. And this is what happens with primitive data types. But we also have object types. And object types, we've seen string as an object type. So here we've got a variable hi, which is declared to be a string object type and initialized to being hello. And hello is in double quotes. So what happens when in memory when this happens? Well, we don't store hello exactly in the memory location referred to by hi. What we actually do is we store the address of where hello is going to be stored somewhere else in memory. In other words, we're storing a reference to where the string is stored in memory. And what I've done here is I've added some green values. These are just made up values, the green on your screen. And what we're saying is we have a variable hi, and it's storing a reference to the string hello, which is stored somewhere in memory. And where hello is stored it's stored in this example in address ffcc. So what would actually get stored in the variable hi position is the address ffcc as opposed to the text hello. So what we're seeing here is there's the difference between values and references. Okay, values for primitive data types, i.e. the value 17, and references for objects. So let's just recap on that. With primitive data variables, example int, float, char, etc., the value of the variable is stored in the memory location assigned to the variable. With object types, the variable holds the memory address of where the object is located, not the values inside the object. This memory address is called a reference to the object. So let's take a look at what happens then when you do an assignment statement. If we take the first example, which is a primitive data type, here we have b is assigned to value a. What we would do is have a variable a, which would need to be declared, and we're putting 17 into it. So the value 17 gets stored in a. When we say b is assigned a value a, what actually happens is we make a copy of what's in a and it gets put into b. So now we have 17 stored in a and 17 stored in b. It's not quite the same with object types. Here we have string a, which is storing the reference to the string hello. So for the object variable a, it's storing the address fb3b in this example. So what happens then when we do b is assigned the value a? Well, it makes a copy of what was in there. And because that copy is in a reference, the reference is copied. So here we find that B gets the address, it gets the same reference to the string hello, but not the value hello. It's the memory location of where hello is stored. Okay, so that's the difference between primitive types and object types. If we compare the two here on the one screen, at the top we're seeing A and B both have memory addresses or references, and at the bottom B is assigned the value A, 17 is copied in both cases. So the assignment statement does the same thing. It copies whatever is stored in the variable, whether that be a value or a reference. Okay, so let's take a look at strings in the Java API. So variables created with the string data type are called objects. Objects are software structures that combine variables and methods. The methods operate on those variables. For example, every string object has a built-in method that can capitalize its letters. You can also convert them to uppercase or to lowercase. Okay, so there's two parts to objects. There's the variable, i.e. the field or the property. These are all words for the same thing. And then there's the methods that operate on those variables. So the name for method being a function. So here, just for the purposes of the notes, is a link to the Java API version 8, which is all of the classes, all of the methods that are in the language. So in there you will come across the string object, and underneath the string object you'll be able to find its properties and all its methods. Again, I've provided those in the web link pod, which you can go to. It might be a little bit overwhelming, so what we've done is, just to get started, we're just giving you a subset of them in the slides today. So if you only want to look at string, because there's lots of other objects, if you only want to look at the strings, then this link will take you just to the section in the API which deals with strings. Now, don't for a minute think you're going to go to these websites and understand everything that's there. I couldn't even tell you what's in every single part of the API. The point is that the language is documented, and this is where you can go to find out the definitive definitions for anything that you want to look up. But we're going to look at a subset by, in the notes, just looking at a few methods. We don't need to know them all. Okay, so here's the methods that we're going to concentrate on for today's class. We have length, which returns the length of a string. We have to lowercase and to uppercase, which converts to upper and lowercase. Trim is an interesting one. The trim will remove leading and trailing spaces that might be in a string. So for example, if you had a load of blank spaces and then you had some text like column followed by a load of blank spaces at the end, when you go to create print statements, you're going to see all these spaces, and what you might prefer to do is to remove those spaces to clean up your output. So trim is one you use quite a bit. We also have substring, and substring will take a big string and you can specify a start and an end point within the string to return a substring. And then we have char at, and this will return the character at a specific location within a string. So you can say at position 5, what is the letter that's in that string. Next we have method calls. So just a slight tangent. We're going to just refer to some terminology here. To use these built-in methods, we must first understand the difference between internal and external method calls. Here's an example of an internal method call, which we've seen before. We had a draw method we called drawX passing in 0. And what we found was that we had to write drawX then in the same file. So here's the example of drawX and what it did. And the point is that when you have an internal method call, the method that you're calling is in the same sketch. It's in the same file that you've written your processing code. Again, just to clear up, This here is the method call. Okay, and over here we have the method definition. So by writing the line draw x 0, you're actually running this code here. And that makes it more efficient for doing more complicated programs. That's what we've been working on now over the last week or two. So drawX is a method call. The sketch is a method with the following signature header, void drawX int gray, and the method calls or invokes a method. So there's another word, invokes, same as calling a method. As the method is in the same sketch, that's the key point, it's in the same sketch, the same processing file, as the call of the method, we call it an internal method call. And the syntax then is just the method name, brackets, parameter list. We also have external method calls, which we're using when we use strings. So we don't know where all the definitions of all the methods that we want to call for strings are. So they are in a separate file and they're in the Java API. So we're actually calling methods that we haven't written. They're not in our file, they're in another file. And when we do that, that's referred to as an external method call. So we want to check the length of this string, name, which is Joe Soap. What we'll be doing is calling the length method, which is in the string API, which we give you a link to. And the call to a method of another object is called an external method call. So we're referring to another object, and the object that we're referring to is the string object, and the string object is defined in the string API, okay, which is part of the language. External method calls have the syntax, and we mentioned dot notation earlier. We've got an object, we've got a dot, and then the method name with the parameter list. So this is the bit that's new. When we have an external method call, we have object dot in front of it. So to find out the length of this string, string name equals Joe Soap, we make the following external method call. So again, external method call, which means we need the name of the object. So it's name dot, and then this is the method that we're calling in the string object name. Again, the arrow is just pointing to the different parts of the call. So what you've actually done there is you've implemented or used something called the dot notation. So Java code can call methods of other objects using this dot notation. The syntax is object.methodName parameter list. So it consists of an object, which is the name, the dot, the method name, and the parameters for the method. Okay, and that's referred to as the dot notation. So some more examples then of using string methods. Here's some examples directly from processing. So 3.9 is using length to give us back the length of the string, in this case stored in a variable called message, which is a variable which is an object type string. So we have print message.length, and it's outputting 33 to the console. Here's another one where we're combining the print statements with string concatenation to build up a message that we're outputting to the string. So in this case, excuse me, we're printing it is message.length characters long. So the bit inside the brackets is the call to the string method, and we're just wrapping some text around it. Another example, converting a string to uppercase and printing it to the console. So here we have a call to uppercase, and you'll see that the message string here is lowercase, but in the output we've now converted that string to uppercase. Another example, we can do the opposite. We can go to lowercase, and it's just another function, another method call, giving you back the lowercase. In this example, there was only one letter that was in uppercase, which was the I. You can see that the I has been brought to lowercase. Another example, removing all the leading and trailing spaces in a string and printing it to the console. So this is a really common method. Something that you do quite a lot when you're writing programs is to remove characters from strings, and taking off the empty space at the start and end of a string is what we're looking at here. So message.trim is what removes the leading and trailing spaces, and then we have a call to .length, which is going to tell us how long it is after we've trimmed it. And then we have two print statements to show the difference. So you can see in the output here, the first line says the original message, and then we have all this space, and then there's all this space after the error message. The error message is HTTP 404 not found error, but we have all this space in front and after the text string. So that, if you were to count all the characters in that string, it added up to 33. But after you trim the message, we remove those trailing spaces, and now we're just outputting a nice tight string, which is now reduced to 24 characters long. So again, this actually comes up quite a lot. Okay, so that's the materials that we didn't cover the last day. So it's coming up to 5 to 1. I'm going to take a little pause there and present you with a question. We'll take 5 minutes, and you might take a look at this question while you're doing it. If you have any questions, you can add them to Slack as well, and I'll try to deal with those during the break. Okay, so let's just set up 5 minutes, and we'll turn off the mic for 5 and talk to you in a minute. Okay. Okay, nearly there. Okay, and we're back. Let's take a look at the poll that we asked. Let's put it here. And I'm just going to broadcast the results. I did say it was anonymous. So let's take a look at what's going on. So the question was, if A is a string object variable, which stores a reference to the string hello, and B is a string object variable with a reference to the string column, write the code to multiply the length of A by B to the console. Okay, so we can get the length of a string using A.length. And we can get the length of B using B.length. Semicolon at the end and a multiplication in between. So I'm just going to pop that one in. So here we have A.length times B.length. That's what would give us the answer. And we're asked to write the code to multiply the length of A by B to the console. So what will be important is that we put a print line and print line bracket and then close bracket with all of what I just wrote inside. Okay, so most of you got the difficult part, which was the A.length times B.length. Some of you stored that in another variable, but the main bit then is to, once you've stored or once you've captured the lengths, you can multiply the two together, and then it's a print line statement to write them out to the console. So you can see from what you've put up on screen there, most of you have gotten that pretty much correct. So well done, everybody. No problems there. Excellent. Okay, so let's move on then with the next part of our talk. And we'll just bring up the next one. Just 1 second. Okay. So we're going to do a little bit more on strings. So we started before the break on strings, and we're going to do some more work on strings now. So let's see what we're going to cover. In this part of today's class, we're going to look at the index of characters. Strings are a collection of chars, and we're going to see how we can use that information to manipulate strings. We're going to look at char at, substring, and compare to. These are methods that are in the string class that we refer to in the Java API. We'll go back over primitive versus object, which we covered just before the break. And then we look at string identity and equality, some common errors with strings, the null value, which is the default for objects, and then escape sequences. Okay. So here's a string which is an index of characters. So the string that we've got here is Niagara or roar again. Okay, And this is a palindrome. A palindrome means that if you take the middle character, you can print the word backwards and forwards, and it's still the same if you take each character one at a time. So a string holds a sequence of these characters. The first character in a string has an index 0, not index 1, index 0. And this is an important thing to remember, so I would encourage you to make a note of that. Index 0 is where the first character is. So we can see here that char at 0 is n. Okay. We also have the last character in a string has an index of whatever the length of the string is minus 1. So here we have char at the length minus 1 equals an exclamation mark. So let's investigate char at a bit more. So here we have char at 9. So what this says is we want the character that's at index number 9. Remembering though that the first index is not 1, it's actually 0. So in this text string, index 9 is here, and it's going to be a capital O. So the method char at is going to return an O. So let's take a look at this. We have string another palindrome equals Niagara full stop space capital O space roar again exclamation mark. We're also using the char data type, which is a primitive data type. We have a variable called a char, and we're giving it the assignment or assigning it a value which is a character that's returned by calling the char at position 9 from the string another palindrome which we declared on the line above. So from a string we're taking out a single character, which is a primitive data type, and storing that. So again, to remember, indices begin at 0. So the character at index 9 is the capital O, which is the 10th character. Okay, so it's the 10th character in the string stored at index 9. That's the bit that people get confused with. So you might just make a note of that. What it means to have an index beginning at 0 is that the 10th position is going to be at the 9th, the 8th position is going to be at index 7, and so on. Okay, so finding the character located at a specific position in a string. So we have, in this example, we have a string object variable called alphabet, which is here, and it's just the letters of the alphabet. We also have a string called error message 404, which has a specific error message. We have a print line statement, which makes a call to the method char at 3. And in the second print line statement, we have a call to the char at 9. Okay, so what we've got to do is figure out what's going to be returned. So if we take a look at this, position 4 equals index 3. Index 3 is D. So if we take a look at our alphabet up at the top, we have, this is index 0, B is 1, C is 2, and D is index 3. So that's why we have, for char at 3, we're getting the 4th character in the alphabet, not the 3rd. Likewise down at the bottom, we have char at 9, which is going to give us the 10th character in the string. So here we have 1, 2, 3, 4 is the space, 5 is the C, H is 6, 7, 8, 9. So index 9 is char at 9. I've got that right. 3, 4, 5, 6, 7, 8, 9 is the A. Sorry, and we wanted position 10. Sorry, I'm looking at the wrong thing altogether here. Let's just get rid of that. The string I should be looking at is the string on the top, error message 404. So this is the first character, the second, third, fourth, fifth, sixth, seventh, 8, 9, 10. The 10th character is N, which is what's indicated here. Okay, so that's char at, and the output highlighted there. So the next method that we're going to take a look at is substring, and substring uses this indexing into strings to return characters, so that we can pull out a substring from a bigger string. So let's take a look at this. So we have substring. It takes in two parameters. The first one is the beginning index, and the second one is the ending index, and the index being the character number in the string. So again, if we take a look at our given string and we look at this example, which is a substring ROAR, the beginning index would be 11, and the ending index is a little bit of a tricky one. So let me highlight what the notes are. So the substring begins at the specified index, which in our case was 11, to get the R, but it extends to the character at the end index -1. So I put a big star on this because this is quite important. You want to pull out the string roar from that sentence. It's not going to be 11 and 14, it's going to be 11 and 15. And the reason for that is because of this -1. Now, that's just the way the method works. Once you know it, it's not a problem. But if you didn't know it, you might be inclined to put in 14 there and get back one letter short in your substring. Okay, so again, we have the example at the bottom. First line is just declaring the string in the object variable another palindrome, and the second line is string roar. And how are we going to get this string to be roar? Well, we're using the name of the previous string and we're calling this substring method. This is the important bit here. Starting index is 11, which is 11 there, but we passed in the 15. Okay, and the reason for that again is because it's end index -1. So it's subtracting 1 from the 15, which is 14, which will give you 11, 12, 13, and 14, which is those characters there, which is the spelling that we want. Okay, so it's all highlighted in red for you there. Okay, now we've been getting some messages on the Slack over the last 2 weeks about, I've got a solution. You're solving the lab questions, which is fantastic, and particularly at this stage in programming, once you get the program running, that's fantastic. We're really happy with that. A lot of you are not happy with your solutions and you're saying, can I do it a better way? Is there a nicer way of doing it? Is there a shorter way of doing it? So, and I was also asked, would that be an explicit topic or would it be included as we go? So here's an example of how it's included as we go, as well as being explicit. So we've just given you an example, example 4.2 version 1. We can see here that this is the code that I just went through a second ago. We have declaring a variable, another palindrome. We're then creating a second variable called roar, and then we're printing out roar. Now you could do that more efficiently by using less variables. So let's take a look at the second version. So it does exactly the same thing, but what's different this time is that we didn't need the roar variable. We're after getting rid of it, and our call in this case is just making a call using the original string. You don't have to, when you call a method, you don't have to store its return value in a variable. It can be just passed into another method, as we're seeing here. It's passed into print in this example. So we're going to get you to do some examples in a few minutes. We've gone through char-at method, the substring method. Let's take a look at compare to, and then we're going to give you some questions. Okay, so the compare to method is the third method that we're looking at today. It takes in another string. Remember, this is a method within the string class. So in order to call it, you'll be calling it on a particular string. And what it's saying is you can pass in another string to it. So what you'll be doing is comparing two strings. So this compares two strings, big word here, lexicographically, i.e. based on the Unicode value of the characters in the string. If you can't remember about Unicode, just take a look at the end of the last class. We covered that when we introduced strings. So the compare to is a method that returns an integer. Okay, so it returns, it's got a return type, and that is integer, and it's greater than if the result is greater than 0. Sorry, it returns an integer indicating whether this string is greater than, equal to, or less than the argument in another string. So here's an example. So what I'm going to do is I'm going to look at 4 examples, string 1 and string 2. String 2 is the word cat with a capital C, and string 1 is dog. And then we're going to run the exact same program but change the value of string 1 to a lowercase cat. Then we're going to change it to the word animal with a capital A, and then to the word cat with a capital C. And what we're going to look at is the output of the same program just by changing the value of string 1, which will be the first line of code in each of these programs, and we're going to take a look at what the output is going to be. Okay, so what will be printed to the console? Which Boolean expression evaluates to true? So again, we've got a string 1, which is set to dog. We've string 2, which is set to cat, and then we've got some logic. Big if statement. The if statement is comparing string 1 dot compare to string 2. We're testing is it less than 0. If that's the case, then it becomes before it in the alphabet. If it's greater than 0, it comes after. And if it's neither of those two, then the strings are identical. Okay, they're the same. Okay, so I'm just going to put up, yeah, let's do the polls at this stage. So I'm going to flick through these, and then I'm going to give you a chance to answer them. So again, I said we have four example programs. The only difference in each line of code is going to be this first line. We're going to change that from dog to a different value, cat, animal. So let's take a look at the polls. Okay, so let me end that one and bring up a poll. Just bear with me for 1 second. Questions? Okay, looks like I'm going to have to bit. Oh, there they are. Yeah. Okay, let me just bring these to the fore. Okay. So you've got 4 questions, 4 polls, which I'm now going to open up. And I'd like you to have a go, please, at answering these questions. So example 4.3 was the dog. Does dog come before cat in the alphabet? Does it come after cat in the alphabet? Or are the strings identical? Okay. So then the next one's on the top right, which is lowercase cat. for the string compare. And then 4.5 we're using the word animal with a capital A, and 4.6 is cat with a capital C. Okay, and just leave the slides at the bottom just so you can refer to it. So the code is exactly the same except for the first line, and what we're asking you is what is printed out to the console for each of the different programs. And while you're filling that in, if anybody's any questions, you can post those into Slack. I'll take a look at those while you're doing that. So please have a go at each one of the questions. We have 15 answers for the first one and a little less in each of the others. Please go through each of them. Okay, let's take a look at the first one. I'm going to broadcast the results here. So in the first example, we're saying dog comes after cat in the alphabet. So we have a capital D for dog, and yes, that does come after the C, capital C in cat in the alphabet. So most people getting that one correct. That's exactly what we wanted. One incorrect answer. Hopefully you can see where you went wrong. I don't know who you are because this is an anonymous poll. Let's take a look at the next one. We've quite a variance with the next one, 4.4. So let's take a look at this one. So we have lowercase cat. Does this come before uppercase cat in the alphabet? And I suppose you'd need to know, does uppercase come first or does lowercase come first? It can't be the last one. Okay, the strings are not identical. So the important thing here is that a lowercase cat is different to an uppercase cat. It was hard for you to answer that question without knowing, does lowercase come first in the Unicode character set or does uppercase come? And we'll take a look at that on the slides in just a second. So we'll come back to that one. If you answered number 3, be worried because they're not identical. There is a difference between a lowercase and an uppercase. And we've been learning that throughout the course, that programming is case sensitive. So the third option there would not be correct. If we take a look at poll number 4.5, where we've capital A for animal, yes, 100% of you say this comes before cat in the alphabet. That's perfectly correct. Good stuff. Everybody got that right. And the last one, we have uppercase C for cat being identical to the string being tested against. Okay, so both of them are uppercase C for cat, so therefore they're identical. So the only one that caused some trouble is 4.4. We might just take a look at the slides where we've provided the solution to those, and we'll talk through that. Okay, so let's just go through those. So here we have the question, and it was 4.4 was the one giving trouble. And what actually gets printed out is small cat comes after the uppercase C cat. Okay, so what this tells us is that in the character system, uppercase characters have lower numbers and lowercase characters come afterwards. And that might be a bit surprising, but that's how it's stored. So it would be a good idea to make a note of example 4.4 and maybe to test out some more strings by taking that code, running it in processing and trying out different letters, uppercase and lowercase, so you can see what the string compare gives out as values. Okay, so that's an important one to make a note of. One little disclaimer, 4.5 is the animal and 4.6. You'll notice there's a little typo on the slide that should be resolved when we publish again tomorrow. Well, I just copied that the slide is incorrect. The answer is right, but the slide is incorrect. If you notice 4.6 cat, and we see here, I just wanted to highlight that this should actually say cat, like so. So if you've printed out your notes, you might just make that correction. Okay, thanks. So we've just gone through the string methods, char@, substring, and compare. And we're about to move into primitive versus object, which we've already looked at. So we're going to fly over that, and then we'll slow down and take a look at 4, 5, 6, and 7. Okay. So just to recap on earlier in the class, we said object types. We have an example which is string. These are a sequence of characters enclosed by double quotes. We refer to a string as being an object type as opposed to being a primitive type. And it is fully documented in the Java API. The Java API provides information about the string class and lists the methods that can be used on the strings. And we've given you a hyperlink there. The most direct way to create a string is to write string greeting equals hello in double quotes. Of course, you can change the variable name and you can change what the string is. What we learned earlier, which sometimes takes a while to sink in, is a primitive type, for example, integer. The value is stored directly in memory. For object types, let's get this out of the way. For object types, we have string hi equals hello in double quotes. And what we learned was that the hi variable contains a reference, otherwise known as an address, to where the string is stored in memory. And we depicted that by storing a memory location to act as the reference to where the string is stored. So hello is a string. It's stored in memory at location FFCC, so the memory location is what gets stored in the variable. Again, with primitive type variables, the value of the variable is stored in the memory location, and with object types, it's the memory address or the reference is what gets stored in the variable. And we saw how assignment statements work. So we saw if we have A and B, which are integer primitive types, whatever is stored in A, we make an exact copy into B. So in that case, it was 17. And then we have storing of objects, and our object in this case is string. And what we store when we make an assignment is the reference. Okay, so that was stuff we covered earlier, just going back over, just to bring it to memory so that we can identify some issues that come up when we write code that make use of strings. And the first one is string identity versus equality. So we have string input equals by. So this is an input variable called input. It's an object variable of type string, and we're initializing it to BYE in double quotes. So what would actually happen is we have our input variable at the bottom, We have a string by. That string is stored in a memory location somewhere. In this case, it's FB3B. So the assignment statement would actually put FB3B into the input variable. That's what gets stored. So when we have an if statement which has a condition and we want to test this input variable, we might be tempted to use the double equals. Okay. And if we do, what we're going to see is that we want to compare one string with another string. So what we're saying here is if input tested, is it the value BYE? And the problem is, well, maybe you can tell me, what would this return? And if you would answer that in Slack, please. String identity, let's say string what's returned. You can respond to the thread there, please. String what's returned in Slack. What do you think is going to happen here? And maybe ask why as well. Okay, thank you for those answers. That's great. And some of you are still typing. Peter says the memory reference is not equal to a string. Mike said false, as by is not equal to ampersand FB3B. And that's the issue that we're trying to highlight. This initially, when you read the code, looks like it makes sense. It says if the input variable is logically equal to the string BYE, and you might be tempted to think that input is what you're actually doing there is comparing the string by with by, and what I'm saying is you're not. You're actually comparing two different things. What we'd be comparing is the memory location with this other string. Okay, so you're going to get unpredictable results, and you're not going to be happy with the way your program is performing. So that's why we want to highlight it here. So this is referred to as testing identity. Okay, identifying the string. So the answer to the question I posted was it may be false. It may be true. You might be lucky that they are actually just stored in the same location, but the chances are it's going to be false. So when we want to compare if one string is the same as another string, that's called testing for equality. That's really what you want to be doing. You want to be testing for equality. And the way to do that is you're going to have to call the dot equals method. Okay, and that will return what you're looking for. It tests if the string by equals the string by in double quotes. Okay. So again, the first part of this is identity. And the second part is equality. And usually we want to test for equality. Okay, so that's the one you want to remember. It's the dot equals, and it's a method that's in the string class. So first one tests for identity, second one tests for equality. I'll put a big star on this because this is going to trip you up, particularly in programs that are on the way. So please make a note of it. Strings should always be compared using the dot equals method. Okay, the star, I don't give out stars lightly. Okay. Right, next up is some other common errors with strings. Let's take a look at what's wrong here. Have a look at this program and tell me what's wrong with question 1. Strings in Slack by replying to the thread. We're a little slow off the mark here. Oh, thanks. I spoke too soon. So what I'm asking is, there's something wrong with this program. It seems to read fine, but we highlighted a problem a moment ago with identity versus equality, and see if you can figure out what's wrong with this program. Good, you're all on point. This program is using a test for identity rather than a test for equality. We've just said that if you want to compare two strings, you should use the dot equals, and you can see here that they're not using the dot equals method, and that's why we're in trouble. So strings need to use the dot equals method. Here we're using if string 1 is double equals string 2, and what we're saying is that will test for identity, not equality. So in this case here, this bit should have changed to, should have been dot equals string 2. Okay, good stuff. So we have another question for you. Question 2 on strings. Again, in the Slack, you might tell me what's wrong with this program. Some of you had similar problems in the labs when we were just dealing with numbers. Okay. Okay, good. Your answers are fine. That's all good stuff. So the problem again is in the comparison, in the condition. We're testing if num1 and it's a single equals num2, and this is a really common mistake that's made in programming. So let's just recap. This is an assignment statement. Okay, the double equals test for equality, okay, on primitive data types, and it's testing for identity on object data types. And we also had the dot equals method. So again, in this case, what should have happened is instead of if num1 is assigned a value num2, which is an assignment statement, what it should say is if num1 dot equals brackets num2. Okay, well done. Thank you for your responses. Okay, another one is the null statement. So null is a special value in Java. All object variables are initialized to null. So just recap on that. All object variables are initialized to null. Okay. In other words, the memory location when you declare a variable of being an object type, that memory location, it doesn't store a memory location. It stores a special value, and that special value is called null. So null means that the object variable does not have a reference. For example, string 1 below has a reference to the string hello. String 2 below does not have a reference, it is null. Okay, so again, let's just break that down. We have the string hello world. It's stored at memory location FB3B, and when I have the variable string1, which is of type object string, it's storing a reference to hello world. So string 1 is assigned the value hello world. This is what happens. But if we then go and declare a second variable, string 2, which is of type string, what actually gets stored is a special value called null, because the default for an object is null. Okay. So you can assign and test for null. Here's an example. If hours double equals null, so now you're able to test if the string is a null string, and if it is, then you might want to do something. Okay, so that's the null value for initialized objects and strings. Last thing I want to cover in this part is escape sequences. Escape sequences take me back to very old printers, dot matrix printers, and before we had word processors, we used to write programs in order to hand up our written reports, which would make use of escape sequences. So let's take a look at these. When a string is printed, certain single characters that follow a backslash have a special meaning, and the compiler interprets them accordingly. I've given you a link there to what all the special characters are, but I've also got them in a table right here. So what we're saying is you have an escape sequence is the backslash followed by some other character. And when you include these in, for example, a string with a print line statement, it has a certain meaning. So for example, /t is insert a tab in the text at this point. That's the equivalent of putting in, a number of spaces, for example, 4 spaces or 8 spaces. /b, insert a backspace in the text at this point, which moves it backwards. /n is a new line, and we use that quite a lot. This makes the cursor go on to the next line. Related to new line is /r, which is a carriage return. What this used to mean for a printer was the printer head would go back to the start of the line without advancing onto the next line. So this is the way we used to implement bolded text in the early days. We would make the printer print out a line of text, and then before going on to the next line, you might return it back to the start of the line and print certain words a second time. And when the printer went over the word a second time, it gave the look of a bold output. Form feed again comes from the dot matrix world. Form feed means page forward. So this on screen, this might look like clearing the screen. On a printer, it would move on to the next page on your printer. We also have single quote, we have double quote, and we have a backslash character. So the point is, these last 3 you use quite a bit. If you want to output these characters, because using a double quote would close off your string, you need to be able to say, no, I actually want a double quote, and that's where the backslash comes in. Okay. So can I ask you to please use a print line statement? So escape sequences, I'm going to just put in a question in Slack, escape sequences, and I'll call out the question. What I'd like you to do is to give me a print line statement, and inside the print line statement I want you to have a string, and the string is columns class, and that's COLM' space class. So can you write the code for that for me, please, by replying to the thread escape sequences in Slack. Okay. So the point I'm making is that in double quotes, we normally have a print line statement. And inside our quotes, we put a string. And because I want to say columns, C-O-L-M, I can't put in a single apostrophe. If I want a single apostrophe, I have to put in backslash apostrophe and then the S. Okay, so this is why we use these escape sequences and why you need to know about them. Particularly those last three, they will trip you up if you're not aware of them. We use the /n quite a bit and also the /t. These are the ones we use the most. Okay, so thank you for your input there. Looks like you've all got that correct. Well done. Let's just go over some examples. We've already seen the difference between print and print line in Java. So if we say print Java and inside double quotes with a /n, the /n will bring you on to the next line. So even though it's a print statement, it would actually bring you on to the next line. It's the same as saying print line Java. Okay, here's another example. Here we want to put some spaces in front of the word Java. And another way of doing that is to use the /t. Okay, so that's escape sequences. So we've looked at strings as being an index of characters. We've looked at some of the methods, char at, substring, Compareto. We saw the difference between primitive versus object data types. We looked at identity versus equality for strings. We looked at some of the common errors that might come up with strings. We looked at the null value for being the default, and we've just a second ago then gone through some of the escape sequences. Okay. Okay. So I'm just going to take a breather there. I realize it's 10 to 2, but I'm just going to take a couple of minutes and we'll start into our final set. We won't finish it, as I said, but we'll get started. Okay, so I'm going to pause there just for a moment. Take 3 or 4 minutes and we'll start back then on objects and classes. Where am I? Let me just bring this thing up. This is it. Okay. So if you have any questions, you might ask them in the Slack window. I'll try and get to them. If not, I'll do it after class. I'm going to turn off the mic for a couple. Okay, a couple of minutes left. Let's take a look at the topic for today. As I said, we won't get through all the slides, but we'll cover the theory because we've been doing it all day. So it's a good place to just get through this first bit. Okay, so we're all back. Last few minutes, just want to take a look at some theory regarding classes and objects. So we won't cover all of this. We'll probably get maybe the first 1, 2, or 3 points done. Classes and objects is first. So a class defines a group of related methods or functions and fields. So what we're saying is, up till now we've been looking at methods. Let me just try and draw here. So up to now we've been looking at methods. We've been writing lots of methods, and we've also started looking at fields or data, variables, properties. These are all names for the same thing. If you look up the API, which we gave you at the start of class, it will define what all of the objects are for the Java API, and the one we were interested in was string. So here we can see what the documentation shows for the methods. Okay, and we can see that we've used some of these already, char@, for example. So an object is a single instance of a class. In other words, it's an object is created or instantiated from a class. This is a fancy word that you just get used to using. Here's an example. We have A, which is of type string being an object. We initialize it to being hello, and it stores the reference of where hello is being stored. And we've seen that a few times today already. You can think of a class as being a blueprint for a building. So here's the plans, and the object then is when you construct the building. So you use the plans to build the building. The advantage is, though, particularly if you're a developer, you don't want to have a different set of drawings for every building, so you can create multiple instances of the objects. So you can create multiple buildings. You can also think of a class as like a recipe for a cake. So here's your recipe, tells you what to bake, the order that you need to do it. But everybody's going to use that recipe, is going to come up with a different cake. So you end up with multiple cakes, and you can decorate them slightly different. Each individual cake can be made individual. For example, you might put somebody's name on a cake for a different birthday, but the recipe is the same for them all. Many objects can be constructed from a single class definition. Each object must have a unique name within the program. So let's look at properties and methods. So objects are typically related to real-world artifacts. In object-oriented programming, for example Java, you model an object by grouping together related methods, which are the functions, and fields, or the variables or properties. So let's take a look at some examples. Here's an object example for apple. So the object name is apple. It has fields, color and weight, and methods for growing, falling, and rotting. Here's another example with a butterfly. The fields, or the variables or properties, would be the species and the gender, because you have different types of butterflies. And then what can a butterfly do? It can grow, it can flap its wings, or it can land. So these are methods for the butterfly. So what we're doing is we're modeling real-world objects in software using software objects. Another example is a radio. So fields might be the frequency that it's tuned into and the volume that it's playing back at. Things that you can do with your radio: you can turn it on, you can tune it in, you can set the volume. And these methods would be changing the values of frequency and volume in order to be implemented. Another example is a car. Fields: make, model, color, year. And the methods: accelerate, brake, and turn. If we take accelerate, for example, what are you doing when you accelerate? You're changing the speed, okay? So you might want to store that as a property. If we go back to the apple example, the object name is apple, the fields are color and weight, and the methods grow, fall, and rot. So to make a blueprint of an apple, you would have to implement the grow method. It might have inputs for temperature and moisture, and these then can increase the weight field of the apple based on these inputs. So grow might take in the temperature, it might take in the moisture, and it might have some conditional logic based on what those values are. It might change the weight of the apple. Fall could be implemented then by checking the weight, and if it goes above a certain value, it might fall to the ground, so it becomes true. And of course, when an apple falls and hits the ground, then it starts to rot away. So we can start beginning to decrease the value of the weight because it will get lighter, and it'll also start turning brown, so we might want to change the color field as well. So this is how in software we're modeling the real world using objects. We saw earlier that an object is created or instantiated from a class. A class can have many objects created from it, and each object must have a unique name. So here's our apple object, our apple class. So this defines the template, and from it we might create two object variables and initialize those to different values. So we have an example here with Gala and Golden Delicious being two types of apple objects. Each has a unique name and its own copy or values of the fields. So we can see that the Gala apples are red and the Golden Delicious are yellow. So they have a different name and they have different properties. Okay, and each of these is called an instance. Okay. So we can change the state. There are two objects of type apple. Each has a unique name, Gala and Golden Delicious, which we pointed out there. Each object has a different object state, has its own copy of the fields, which are stored in memory, and it has its own data stored in these fields, so for color and weight. Okay, just about finished. I'm going to stop after this, which is the dot, because it makes sense just to keep going for 1 minute. The fields and methods of an object are accessed with the dot operator. Now you've been doing this all this week and last week. So here we have object.property and object.method. Now you've done this already today when you called the length method to see the length of a string. You were using object.method. And we've just got some examples for our apple. So we can say gala.color to get at the color value, golden delicious.color. So Gala was red and the Golden Delicious was yellow. So this is how we would get those values back. We can also call the methods, so Gala grow and Golden Delicious dot fall. Okay, so the important thing here is we're using object dot property and object dot method, and that is the object notation. And I'm going to draw a line there, and that's where we're going to stop, and we'll pick up from here the next day. Thanks very much for staying with us today. That's the end of our class. Once again, if you have any issues, any questions, please feel free to ask them in Slack. As you know, we'll get back to you as soon as possible. Okay, so thank you very much, and I'm going to close the meeting there. Thank you.